Welcome everybody to your second video lesson for Unit 8 on System of Equations. Today we're going to talk about solving systems of linear equations through the use of substitution. So let's jump right into it again. As we go through this, make sure you have your note packet right next to you, ready to follow along. Feel free to pause, rewind the video at any point. Okay, up to this point we talked about how to solve systems of linear equations through graphing, where we would graph both equations and see that point of intersection, and that point is our solution, value of x and y that both equations would have in common. Today we are going to talk about substitution. Okay, so it's going to be a little different method, a little more work mathematically, but now this is kind of the algebraic approach, meaning actually using some methods of algebra, not just graphing, to actually solve. Okay, so here's what I want you to think about.
Roses are red, violets are blue. Splenda is sweet, and so are you.
Just about anywhere you use sugar, you can use Splenda no-calorie sweetener. Splenda lets you experience the joy of sugar without all the calories. It's a very good reason to enjoy something sweet with the ones you love. Think sugar, say Splenda.
Well, how touching is that? Geez, I think I have a couple tears running down my cheeks right now. But I want you to think about that. When we're talking about substitution, think sugar and Splenda. Substitution means you can replace something with another thing that is really the same. So sugar and Splenda. Splenda is a sugar substitute. It's similar to sugar. It's not sugar, but it's almost the exact same thing. Okay, we're going to do the same kind of idea, but with math. Substitution, we're going to replace one thing with another. Okay, so let's take a look at how we solve systems of equations through substitution. So make sure you follow along with these steps. They should be on your notepad. So step one, what we're going to do is we're going to take one of our equations. So again, a system, you're going to have two equations. Say y equals 2x plus 4 and 2x plus 3y equals 6, something like that. What you're going to do is you're going to take one of your equations. So if this is my system, I'm going to look at one of them, and I'm going to take one of them and solve for one of the variables. So remember, in a system, we're going to have both y and x. We have two variables. We're going to solve for one of them. Okay? When possible, it says here solve for a number that has a coefficient of 1. Now, what does that mean, coefficient of 1? For example, if I look at my two equations I have here, y, notice it's by itself. That doesn't mean that it has nothing in front of it, but really it is 1y. So it has a coefficient of 1. The number in front of it is the coefficient. Okay, so that's good. Then what we're going to do is we're going to take one of the equations. Once we solve for one of the variables, we're going to take that equation and we are going to substitute it, and this is a key part, substitute it into the other equation. Meaning, for the example of this means y equals, this equation is basically telling me sugar and Splenda. This is what y is equal to. Y is 2x plus 4. So, in the other equation, I can take this expression of 2x plus 4 and plug it in for y. Substitute it in, replace it for y. Once I have that, then I am going to have one single equation, and I can then solve for that variable. Okay, so it says we're going to plug it into step 1, or the equation from step 1, plug it into the other one, and solve. Once I solve for one of the variables, then I can take that variable, say y equals or x equals whatever number it is, and now I can take that value and plug it back into one of my original equations and solve for the other variable. Okay? What that then is going to give me, that's going to give me a value of x and a value of y, and then that is my solution, which again we write as a point of x comma y. Okay? Now, obviously talking through the steps, not going to make much sense, but we'll go through some examples. I'm going to take you in this next example step by step on how to solve. All right, so here's our first example. We're going to solve this through substitution. So I have my two equations. Equation 1, 4x plus 6y equals 4. Notice that this is in standard form. X equals negative 6 plus 2y. So, first step is to take one of my equation and solve for one of its variables. So if I look at my two equations, here's what I want. From step 1, I want either y equals something or x equals something. I want one of my equations to solve basically have a variable by itself, everything else on the other side. Now, if you look closely at this problem, I see my second equation, x equals. So, step 1 is already done and taken care of it for us. We have x equals -6 plus 2y. So I've now taken one of my equations and solved for one of the variables. Already done for me. Okay, step 2 then is to take this first equation, x equals, and it says now substitute the expression. Okay, so the expression, I am going to substitute this portion because this is what x is equal to. This is like sugar, this is like Splenda. We are now going to take the Splenda and we're going to plug it into the other equation. Okay, so my other equation, do that in blue, is 4x plus 6y equals 4. Now, what I know is I know that x is equal to -6 plus 4y. This is sugar, this is Splenda. This is sugar. Let's now replace the sugar with Splenda. So I'm going to take 4. I am then going to replace that x with what x is equal to, -6 plus 2y. And I leave everything else. So plus 6y equals 4. Okay? Now notice I have an equation with y and y. So I have one equation with a single variable. Now I can solve. Okay? So I'm going to go ahead and solve this. So first of all, I see 4 parentheses -6 plus 2y. I should know right away I'm going to distribute my 4 to each of those. So that's going to give me, I'll write on the right here, -24 plus 8y plus 6y equals 4. Okay? Combine like terms here. I see 8y and 6y. Combined, they're both positive. I have -24 plus 14y equals 4. Then I see, okay, I want to get y by itself. I have multiplying by 14, adding -24. I want to get rid of the 24. I see it's negative. I'm going to add it. Add it there. I get 14y equals 28. Last step, divide by 14. Get that to cancel out. Divide by 14. And what I now know is that y is equal to 2. So what I've done is I've taken my sugar. I know that this is Splenda. I've plugged it into my equation. I now was able to solve for y. Step number 3, once I know what y is, I'm going to take y equals 2 and I'm going to substitute this into one of the equations. I now know what y equals. Now which equation doesn't matter. I can choose any one. I'm going to go back to my original one. X equals -6 plus 2y. Why would I plug it in there? Because this equation says x equals. By plugging in y, it's going to tell me what x is going to be. So I'm going to plug in -6 plus 2 times y, which is 2. And then I can simplify. So 2 times 2, I'm going to do that first. So that's -6 plus 4. -6 plus 4 is -2. So I know that -2 equals x. So then the last step is this is my solution of x and y. I'm going to express my solution as a point. So remember, a point is always x comma y. So my solution is going to be -2, 2. Okay? Think about what we did in the previous lesson about graphing. We have now taken this point here, or these two equations, and instead of solving by graphing, we have now solved through substitution. Same process, obviously a little bit more work, but it's the same kind of idea. Okay, let's do some more examples first. Let's take a look at example 2. Now this one, example 2, I'll work with you, then I'm going to let you go on your own for a little bit to practice. Okay, so I have my two equations, y equals -7 minus 3x and -2x plus 4y equals 0. Step 1 is I'm going to take one of these equations and solve for a variable. Should notice right away my first equation is already solved for y. So again, what this tells me is it tells me that y is equal to -7 minus 3x. So since that's what y is equal to, think again sugar and Splenda. We are now going to take what y is equal to and plug that in, substitute that into the other equation. So I'm going to take this y and plug that in for that. Okay, so I have -2x plus 4. Now instead of y, I'm going to plug in what y is equal to, -7 minus 3x. And all that's equals 0. So again, I replaced y with what y is equal to. Replaced y with what y is equal to. Now I have x and x. Now I can solve. So I have -2x. I see here I got to distribute the 4 just like we did in the previous example. So 4 times negative 7 is negative 28. 4 times negative 3x is going to be negative 12x. That's equal to 0. Combine like terms, negative 2 minus 12. That's going to be negative 14x minus 28 equals 0. Have to get x by itself, so I'm going to add 28 to the other side. So I get negative 14x equals 28. Divide by negative 14, so it cancels out, to give me x equals 28 divided by negative 14 is negative 2. So that's what y is equal to. And once I know what y is, I'm going to take that and plug it back in for y in my original equation. So, or sorry, for x, not for y, my fault. X is equal to negative 2, I'm going to plug this in for x over here. So my second equation then, or first, was y equals negative 7 minus 3 times. I'm going to plug in, instead of x, I'm going to plug in what x is equal to. Substitute that in, replace it. Then simplify. I see negative 3 times negative 2. I'm going to simplify that first. That is going to be plus 6. Then I have negative 7 plus 6. That's going to give me negative 1. So I now know what y is. I now know what x is. So I'm going to express my solution as a point of negative 2, negative 1, x comma y. Okay? Alright, going on. I want you guys right now to pause and work on example 3. Pause and work on example 3. I'm going to show you the solution in just a second. Here we go. Okay, take a look at this one. Here we go. Two equations. X equals 2y plus 5. X equals 10 minus 3y. You should notice right away, first step, solve for one of the variables. I should notice both equations are solved for x. Don't get confused by this. You know x equals this, x equals that. Take the first equation. I know x is 2y plus 5. I'm going to take that and plug it into x for the other equation. Replace it. Okay? That's going to give me 2y plus 5 equals 10 minus 3y. This one a little different. I have y's on both sides of the equations. I need to get them on one side. So I added 3y over here to get 5y plus 5 equals 10. Solve for y, got y equals 1. Then I took y equals 1 and I substituted it into my original equation of x equals 2y plus 5. Plugged in 1 for y, simplified, solved, got x equals 7. So therefore my solution, my point, is 7 comma 1. Alright, let me do number 4 with you guys. So I have x minus 1 equals y. 2x minus y equals 5. This one looks a little different. Okay, first step, solve for one of the variables, substitute it into the other equation. So I look at this one. Okay, I have x minus 1. I have 2x minus y. Doesn't look like it's solved for variable. If we look closely, okay, I have x minus 1 equals y. This is telling me that y is equal to x minus 1. Remember, it doesn't matter how I write the equation. This is just flip-flop, means the same thing. So this tells me what y is. I'm going to take this. If y is equal to x minus 1, I'm going to take x minus 1 and plug it in to y in the other equation. So that's going to be 2x minus, okay, parentheses, this is important, x minus 1. Now, what is the number here? What is the coefficient in front of y? This is a little tricky. The coefficient here, remember, just by itself, that means it's 1. So I have negative 1 times x minus 1 equals 5. That's going to help us out because now, again, I'm going to have to distribute. Notice that there's a lot of distributing going on here. So I get 2x. Negative 1 times x is negative 1x. Negative 1 times negative 1 is plus 1. That's going to equal 5. Then I have 2x minus 1x. That's going to give me 1x. Plus 1 equals 5. 1x I can just write as x, so I can subtract the 1, and I'm going to get x equals 4. Okay? Once I have x equals 4, my goal then is I'm going to take this x and I'm going to plug it in to the x up there. So I have y equals x minus 1. I'm going to plug in x, so y equals 4 minus 1. Simplify, y equals 3. My solution then, x comma y, is going to be 4 comma 3. And that is my solution. Okay, from there, I want you to take a look at number 5, our last example here today, and I want you to stop, pause, and solve quickly with number 5. Before you pause and solve, notice that this one, a little tricky. Follow step 1. You have variables on both sides of the equation. You must solve for one variable first. Here we go. Give it a shot. All right, step 1. Take your equations. I see both of them have variables on both sides. I need to get one by itself. says choose the one with a coefficient of 1. I look at the first equation, x and y both have a coefficient of 1. So I took that equation, and what I did is I decided, hey, I'm going to get x by itself. So what I did is I added y. Got rid of y to bring it to the other side. You do the opposite. So subtraction, I added y to the other side. Got x equals 3 plus y. That again tells me what x equals. I took 3 plus y, plugged it into the other equation here. Plugged it in for x, replaced it, substituted it, and solved for y to get y equals -1. Okay, check your work there. Make sure you distributed correctly. Once I got y equals -1, took y, plugged it back into my original equation for x, and I got x equals 3 plus -1. Solved for x, got 2. Therefore, my solution is 2, -1. Okay, so again, if you need to stop and rewind this video, that's going to conclude this video on solving through substitution. If you need to go back and rewind and look at any other sections, please feel free to do so now. All right, we'll see you later. Have a great day.